So, as mentioned previously, um, on continuous spans, when you design for tension at the top, um, this is just a short elaboration on showing you guys a way to actually design for tension bars in your top area of your beam. And usually it's where you have columns, because as you can see in my free sketch, where we bend upwards, it's going to be in tension. It's going to be in tension, and this is a tension zone, tension zone, tension zone. So we have tensions steel at the bottom, where it basically sags, and then we have tension steel where it hogs, and it usually looks like that. We have your tension steel at the top, and then you have your tension steel at the bottom, in the middle where it spins, and then usually you put one bar straight through, but that bar running straight through, that's just to prevent shear, or that's just to prevent, because usually you will get tension sometimes at the bottom, you know, of your columns, but that's only in cases where we have earthquakes. And I think I mentioned somewhere, I'm just gonna read, I think I mentioned somewhere where the reason why we do it is to prevent, why we put one bar straight through is in cases of when we have heavy wind loads and when there's earthquakes, then usually you get some type of tension in the bottom section of your column, where your column runs through your beam. But that's why you have to put it one steel piece straight through. It's usually a very, depending also on your design, usually it's not a big steel, or the cross section of the steel isn't that big. But now I'm just gonna read over everything, the notes that I made. Now this one states a continuous beam bends downwards in the middle portion of each span and upwards in the portion around the supports. So it's bending upwards around the supports, and it's bending downwards in the span area. That's for that section. Now this one states they are sometimes stirrups are sometimes spaced more closely near columns where the diagonal tension forces are highest. So which means that that's the point that I meant previously in my previous video. That's where we put stirrups close to each other. That's just to prevent shearing. And then we state top reinforcement are required in the zone of upwards bending. So everywhere where we have upwards bending, we're going to put top steel, or we're going to design for tension steel. And then this one states a right angle beam, a right angle bend is used in place of a hook where there is sufficient space for it in the concrete. Okay, so right angle beam, right angle bend, that's just, to prevent cracking. That's why you want to basically do a bend down. And then you have your bottom bars are heaviest in the center portion of the span and lighter. This is what I was talking about. And lighter through the column, where some bottom tensile forces can occur during strong winds or earthquakes. So that's basically the theory of where you want to put your steel when you design continuous beams.